Hello everyone, this is your Lekkala Mastaru. In this video, I am going to discuss a problem from RMO Regional Mathematics Olympiad, which was given in the year 2007, and this problem was built on a most neglected and simple concept from 9th class geometry concepts. Why I am using this word most neglected? Why? Because if you have the word geometry, immediately we used to recall so many different theorems and concepts from geometry like Pythagoras theorem, basic proportionality theorem, midpoint theorem, like circles, triangles, etc. etc. But in 9th class, there is a very innocent or so simple concept was there, and we have only 4 to 5 different problems on that one. Later on, we used to forget about that one. We used to just neglect that one like anything. But that problem in the year 2007 in Regional Mathematics Olympiad, what was given is completely built on that concept, what I am going to explain now. So before introducing the question, let me explain the concept first. So as a statement first, let me explain. In any triangle, larger side contains larger angle opposite to it, or vice versa, larger angle contains larger side opposite to it. The meaning of this one is, just imagine a right triangle ABC. We know that angle B is 90 degrees here, and this is the larger angle among all the 3 angles of ABC, where it is 90 degrees, and remaining 2 angles are going to be acute angles for us. Now, the side opposite to angle B, what is that? AC. AC is the longest side among all the 3 sides of ABC. Usually we call as a hypotenuse. So not only in right triangle, suppose if you take any acute angle triangle or any other triangle, I call angle B is greater than angle C. So if angle B is greater than angle C, if you see the side opposite to angle B, which is nothing but AC, is greater than the side opposite to angle C, which is nothing but AB. So as angle B is greater than angle C, simply we can say AC is greater than AB. So the larger angle contains larger side opposite to it, or larger side contains larger angle opposite to it. The most innocent and important concept we have learned in 9th class, and we have done more 4 or 5 problems on this one. And one more small thing, just have a look here. Suppose we take a triangle ABC. Now here, what I am doing, from B, let me draw a line which intersects AC at some point D. So BD is just a CVN or a line which intersects AC at D. So now what I am doing here, on BC, let me take a point P, something P. So now from P, on BD and on BA, let me drop 2 perpendiculars. 2 perpendiculars. I call first perpendicular on BD as H1, on BA as H2. Now observe this, the things carefully here. Angle CBD is definitely smaller than angle CBA. Clearly I call as something alpha and beta. Alpha is smaller than beta. Now observe this carefully, H1 and H2. Both are the altitudes drawn from the point P to the BD and BA. Now just by looking at the diagram, we can say H1 is smaller than H2. Why? Because the related angle is alpha is smaller than beta. Definitely H1 will be less than H2. We used to call as acuteness of triangle. So these are the only 2 things which are going to helpful in this problem, and it's a most tricky problem based on a simple and neglected concept. So now without wasting time, let me explain the question from Regional Mathematics Olympiad 2007. So here what was given? ABC is an any acute angled triangle. So ABC is acute angled triangle. From vertex A, an angular bisector was drawn which cuts BC at some point called as a D. So now AD is angular bisector, so these 2 angles are going to be equal. Let us take it as something theta. So now from B, they dropped a perpendicular to AC. They call as E is the foot of perpendicular. So now simply they are asking, if I join ED, angle CED, whatever the angle you can see here, this is greater than 45. They are asking to prove that angle CED is greater than 45. So most tricky problem, most typical problem to understand, to solve, to apply the things whatever I explained in this particular one. So the beauty of entire problem lies in the construction. How we are going to change the diagram according to our requirement is the beauty behind this problem. So now angle CED is greater than 45, what we need to prove here. So now what I'm doing here, the immediately as a first step, from D, whatever the foot of angular bisector, let me drop two perpendiculars to the AB as well as AC. So I call as this as DP and this as DQ. Now observe these two triangles carefully, APD, AQD. In these two triangles, observe carefully, these two angles are equal, theta and theta, and P and D are equal to 90 degrees, and AD is a common side. So simply angle side, we can say these two triangles are congruent to each other. So without giving much explanation for this one, just I am writing triangle ADP is congruent to triangle ADQ. In bracket I am writing as AAS congruency. If these two are congruent, can I say that DP is equals to DQ? So let me write as DP is equals to DQ. Name it as equation 1. Now one more small construction I am doing here. What are this? From D on BE, let me drop a perpendicular. So I call P over Q over, I call as R. DR is the perpendicular to BE. So now here what I am doing, observe this carefully, DR and DP. Comparison between these two, DR and DP. Angle CBE is smaller than angle CBA. From the diagram you can see we call as something X and Y or alpha and beta, whatever it is, the angles. So angle CBE is smaller than angle CBA. So definitely, as I said, acuteness of triangle DR is definitely smaller than DP. Let me write DR is smaller than DP. I call as acuteness of triangle, and let me write as a equation 2. So now in place of DP, from equation 1, can I replace DQ? So let me write DQ is greater than DR or DR is less than DQ. DR is less than DQ. Now I call this as equation 2. Now observe this carefully, DREQ. DREQ. So angle R 90 degrees, angle E 90 degrees, angle Q 90 degrees according to constructions and the problems. Definitely the leftover fourth angle is also going to be 90 degrees, which implies that DREQ is a rectangle. In rectangle, opposite sides are equal. What does it mean? Can I replace DR with EQ? So now here EQ is smaller than DQ. What we can say? EQ is smaller than DQ. EQ is here, DQ is here. So now just to take this triangle here, EQD triangle, I call that D as beta and angle E is alpha. So now EQ is smaller than DQ we got. So let me write EQ is smaller than DQ. So as I said, larger angle contains larger side, smaller angle contains smaller side, opposite to them. So can I say angle beta is lesser than angle alpha? So angles opposite to them. So now adding alpha on both sides, what you are going to get? So alpha plus beta is smaller than 2 alpha, what you will get? So alpha plus beta, which gives us 90 degrees. Why? Because it's a right triangle. So clearly we can say 90 degrees is smaller than 2 alpha. If you transpose 45 is smaller than alpha, what does it mean? Alpha is greater than 45. What is alpha here or what is alpha there? So angle QED is alpha. Not only angle QED, we can consider as angle CED is alpha, which is greater than 45. That's what we are supposed to write. So therefore angle CED is greater than 45. So my dear children, you have to understand how beautifully, how trickily the entire problem was solved based on a simple concept. That's what we have to learn. So my intention is, even from our regular textbook, based on a simple concepts also, we can expect some Olympiad level problems, and which can be solvable in most elegant way. That's what I want to say from these problems. Hope you enjoyed this problem. We'll meet in the next video with other topic problems. Until then, take care. Bye-bye. Your Lekkala Mastaru Haragopal.